Okay. All right. Am I on? Okay. Can I get a mic check, please?
Loud and clear.
All right. Thanks. So last time we used Docker to right. Sorry. can I make sure everyone can see the Jamboard on my screen?
Yep.
We see page
thanks.
6.
Page 6. Thank you.
Yeah.
So last time we used Docker to pull down an image from Docker Hub, and then using that blueprint, we created a container using that image as a blueprint, create a container. And then we're able to run it, and then we had to like set up some ports so that our browser and our host can then interact with the container, which was running like a web server. Today we're going to do pretty much the same thing, but with Docker Compose. And you know, one of the reasons why might be if you notice when we're running the commands with Docker, you had to put in a lot of parameters or options or flags. And so, like, for instance, the ports. Where's the ports? Here you go. So here's the ports. And you know, as your app is more complex, you're gonna have more flags, such as you probably want to mount your code into the container, and you probably want to connect it to a database container. And if you run multiple containers, this Docker run gets a little bit tedious to kind of like keep track of. So Docker Compose allows you to use a YML file, a YAML file. It's a file format that's really good for configurations and settings. So it allows you to define your configurations in a file so that you don't need to worry about all the parameters. And you just need to use one command, Docker Compose up, and all the parameters are acknowledged or recognized. And additionally, because it's in a file, you can now share the file in your Git and share it with the team. So if you get a container to run on your machine with Docker Compose up, someone else's machine with containers set up and issue Docker Compose up will have the exact same setup. And you know, prior to Docker, it just wasn't that easy. Prior to containers, onboarding a new developer and getting their development machine set up properly to match the team's stack and dependencies and have the application run. Depending on the experience of the developer, it could run into weeks. So this is something Docker has helped, containers have helped out with, and Docker Compose is just that much nicer than using straight Docker in terms of affording that luxury. And then if you've heard of the term infrastructure as code, this is kind of it. You could have a shell script that runs these commands, but it's a little bit more brittle. If you understand imperative step-by-step instructions versus a declarative where I just want these ports. I don't care if the container is previously running or not. It's not step-by-step instructions. You just declare what you want in the end state. So that's a little bit better because as the end user of this compose file, I just tell it what I want, and I don't care the steps that does it. So you letting the smart people at building Docker Compose figure that part out. Like they'll probably check if the container is running, if it's stopped, if the image needs to be brought down. So so it's just a layer of an extra layer of abstraction, and it just frees me from worrying about those little gritty, nitty bitty details. So that's kind of why we want to use Docker Compose. So to summarize, it is you can capture everything in a file, and you can source control that file in Git and share that file. And also, it is declarative. You don't need to worry about what steps you took. Is the container running? Is it stopped? So those are the main benefits of Docker Compose, and let's dive into that right now. Before I do, any questions, comments, or concerns? Okay, so we're gonna try to do exactly the same thing, but with Docker Compose. So the first step we did was download the image. So let's do that. So here from yesterday, we made this Git repo, which we didn't use because there was no files involved with using just straight Docker. So Docker Compose recognizes this Docker Compose YML. And once you have this YML, code is probably going to ask you to download a few extensions. It just helps with syntax highlighting, if anything. It's your choice if you want to install it. But this one is a actual extension if you want to see the images and running containers. So I'm going to see if I can actually, yeah, I don't think it's going to, oh, I can actually remove it from here. Let's do that. Let's remove this so we can start from the beginning. Okay, so let's do the same thing from the command line. I think it's just remove. Yeah, remove. So Docker image remove, and we'll just give Nginx. And there is it's been removed from our local repository of images. All right, so now we'll have Docker Compose, and I'm just gonna copy it here since it's available. Actually, I don't think. Well, let's see if it works. So I'm just gonna take this first, and with YAML, it is very particular about spaces and tabs. So try to use spaces, and I think my IDE is set up where it replaces tabs with spaces, and also just a personal preference. Tend to like 2 spaces to save on space. All right, I have to fix that later. We'll do 4 spaces for now. Okay, let's see if that works. If we do Docker compose, and to check if your Docker compose is installed properly, you can do this version. So we're going to pull the images down. And we should be able to see it here in a little bit. So that was the first step. Going back to our diagram, this is what we're doing right now. Pulling it down. And you notice that the output is a little bit different than what Docker's output is. But it's the same exact thing behind the scenes. Okay, so now it's done, and we have our image downloaded. We list images. We again see our Nginx. Okay, try to get a little bit bigger. Oops. The version is optional. It's best practice probably, but as you can tell, it works. So definitely, if you have, yeah, I would just use a version, but it's not required. And to show what the version looks like, we can do something like this. So this is the version. And I think with the version, you're able to, I don't know, maybe like if you don't have the version, it's gonna use whichever version is installed. But if you specify the version, you can maybe have more compatibility. So if we were to do it again, it should be the same. And were there any other questions? Okay. So what's the next step here? We download the image. So now we have to run the image. So to run the image, we just do Docker compose up. And this will run anything specified within the YAML. So if you wanted 2 web servers, you can do this, and it'll actually run 2 web servers. So we do Docker compose up. Right now, no containers are running. And if we were to check through the command line and do a Docker PS, nothing's running. So we do Docker compose up. Okay. So it says we should use version 3.3. Oh wait, actually, I forgot the services. So I forgot this services key. And then I have to nest these services under that key. Okay, so it should still be the same. We do a poll. It should recognize that it's using the same Nginx image and it's already downloaded. We do Docker compose up. Now it's creating the containers. You'll see it being created, and eventually it'll start running. And you'll see that the name of the service, and then it'll tell you what log is kind of popping up within the container. So this, I guess, eventually the command line, they're updating it to combine Docker and Docker Compose. So for this class, we're just gonna continue using Docker-Compose, just because I don't wanna change things mid-semester or midterm, and I tend to like to wait a bit because the first release of certain products is usually not as polished. So now, if we do Docker PS, it will tell us that we have 2 containers running, and Docker Compose actually names it with something that's useful. So this is the parent folder, Docker Compose container _ demo, and then this is the name of the service, which is web and web 2. And then you can use Docker Compose to run multiple versions. So instead of having 2 services of the same thing, you would have 1 service and run it 2 times, which is more ideal. But you might want to have, that's not to say you might not have 2 Nginx containers running. 1 Nginx might be serving a page regarding, one Nginx might be serving website A, and another Nginx might be serving website B. So that's not to say you shouldn't have multiple services. It's just if you have the same exact service, which we have now, it's probably better to just have 1 service and scale out to 2 containers. Okay, so here, this is where Docker Compose, I think, is better than straight Docker, because we can say down, and it'll bring down both containers. And here we have our command line back. You could run it in the background if you gave it a flag. I think there's a daemon background option. Docker Compose. Oh, no. So yeah, detach is how you run it in the background. So if you want your terminal back, you can say Docker Compose detach, and then it'll run it, but then give you back your terminal. So here we should see the containers come up. And then we have our containers back, terminal back. So again, if we do Docker PS, we see that both containers. But it's very easy to forget which containers are running. So I generally do not run it in the background. Okay, so here we did exactly the same thing. We have containers running, and our next step would be to have our browser interact with the container, and we need this setting right here. And to do that, well, let me just show you what it's like when we don't have that setting. We'll have 2 containers running, and then our browser. If we go to local 80 80. It doesn't go anywhere. Containers are running, but it's not forwarding the request to containers. So we can do a Control C, and it should stop. It stopped here. Okay, so now let's set up our ports. So we're gonna map the host port of 8080 to the container port of 80. Okay, so let's do that. It actually created a new container. Well, got rid of the old ones. So yeah, Docker Compose is doing all this management of stopped and stale containers for you, so you don't have to kind of manage all of that. So Docker Compose, PS will tell you that we have 2 running and that the host port 8080 is being forwarded to the container port 80 for 1 out of the 2 containers. I think Docker Compose has a PS. Yeah. So similar information, but it abstracts you away from the actual running. I don't know. It shows you what you need to know, and this stuff you kind of need to know if you're using Docker directly. But at the Docker Compose level, it knows that you don't really care about the container ID because we're using the names based on the service names. Okay, so now if we go to port 8080, we should be able to see our splash page. Now, in your exercise, you're gonna have to run 2 services. The other one is a Tomcat server, which I won't go into. I'll leave that bit of learning for you to do on your own. But I guess I'll go over what's like to run 2 containers. So if I were to copy and paste, it's going to say, the host port 8080 forward to the web container port 80, and host port 8080 forward to the web 2 containers 80. But that's a conflict. Your host machine only has 1 port 8080. So this should error, and you should have some sort of error message talking about conflicting ports. So let's bring down our running containers, and we'll bring it back up. And we should have an error. Yeah, so it's saying the port's not available because it's already in use by one of the other containers. But it did start running the first one for you. So one of them is working, but the other one is not because it couldn't start up properly because it didn't know what to do. So let's bring it down. And I'll give you another feature, go through another feature of the Docker thing. If I don't specify the host port, and I bring it up again. If we do the PS command, you'll notice that for web service 1, we have the host 8080 forwarded to the container 80. And for the second web 2 container, it just chose a random port on your host. So we go to 50459. So this is working. This isn't, because we're not using 8081. But if we go to this port, this is our second container running. So that might be a feature if you just need to pick some arbitrary part. But most of the time, I think you want to specify and know what and where your containers are running and listening on. So let's introduce you to this other command. Let's restart web 2 now that we have a new configuration for the web 2 service. And let's see if that port setting gets picked up. So the restart is useful because sometimes, depending on the application, some containers you need to restart the entire container to pick up the change. So this way you don't have to like stop all the containers and restart all the containers. You can just stop and restart one of them. You know how like for Java apps you need to recompile, so the container kind of needs to go through the compiling again. So that's useful there. But most of the modern frameworks and languages, if it notices change in the file system, it just automatically updates. But sometimes you need this restart. So here, I guess the restart didn't pick up the change. In this particular case, we need to bring everything down. And there's another one to remove. So there's a way to show stopped containers. Okay. But anyways, so I think the container just should be stopped. But if you want to remove it, there's this remove command. Oh, maybe down does the remove for you. But remove is there as well. I think it's useful for volumes. Okay. Maybe it's, we'll try that again later. So let's bring it up, and hopefully our new port is recognized. So here, it's not using an arbitrary port anymore. It's using 8081. So our arbitrary port number is no longer there listening, but our 8081 is there. And our 8080 is being redirected to the proper container. So I think what I was trying to show at first was Docker Compose stop. And it should stop the containers, but not remove them. Now we do Docker Compose PS. The containers are there, but they're stopped. And I'm curious what Docker says about them. Here, yeah. So they're stopped, and it shows up as stopped here. So this is when you would need to use Docker compose remove to actually remove the container. So yes, for that one. So here's the thing about containers. They're almost like your regular computer, right? You can turn on, boot up, shut down your computer, and then boot up and shut down your computer. Or you can throw your computer out the window and destroy it. So the remove actually destroys it. It's gone forever. The start and stop is kind of like shutting down and rebooting and starting back up. So hopefully that helps with understanding what we just exercised there. And I think that's it. We've gone through everything here. Everything we've done in Docker, we just redid it in Docker Compose, and I hope you can see the value of Docker Compose. And then I guess the last thing is to share this. So if I can do it quickly, I'll try here, but I might not try too hard. Okay, so okay, what do we call it? Container demo. Okay. So here we're going to add our newly created container. Remote, add our remote. We'll call it origin. Now we're going to commit this guy. Adding file from demonstration. And then we'll push it. Yeah. And that looks good. Have the unicorn. And here's our Docker Compose by Mel, should you want to refer back to it. And this is the value of using Docker Compose, right? With this file, you share this repo with someone else and they can basically replicate exactly what you just did. Whereas using Docker Compose, you have to script it out and share the script, but scripts are really brittle. Certain steps might be out of order and it's just a headache. So declarative, prefer declarative over imperative. So yeah, if you want more on that, declarative versus imperative. Okay, I think that's good. That's all I have. Any questions, comments, concerns?
I was wondering, for the container port, can we choose any number for that port, or is that set based on the Nginx?
Oh, I see. You're talking about the 80?
Mm-hmm.
Yeah. That is set by the container you're using. And just to be clear, the host container port, the host port, you can choose whichever you want. And let's just show you why that is. So at a later time, we will be using Docker files. So normally, like the Nginx, we would put here, and then we'll build on top of that image. Like, remember how we said containers or images are like cakes, you just add layers. So here, they're using this base image to build the Nginx container, and they're layering these instructions. So here, within this instruction, they're calling out port 80. So if you wanted to change it, what you would do is you copy this Docker file, and then just change this to the port that you want, and then you would build everything off of this Docker file instead of pulling it from the pre-made image on Docker Hub. And that's just how Nginx does it. For other applications and images, you can run it, and there might be an environment variable you set, and it'll pick up that environment variable and then set the port to that. So this is just how Nginx decided to structure and organize their container, but other container and images, they can do it slightly different. I hope that helps. But I gave you more info than you're asking. But yeah, cool. Anything else regarding that, following up on that, or something new other than that? Thanks for the question. I'm trying to think if there was a part about Docker files. But anyways, I'll stop the video here. Let's see if anyone else has questions off record.